Chapter 3. The Origin of the Moon. The best explanation for the moon is observational error. The moon does not exist. Attributed to Erwin Shapiro of the Harvard-Smithsonian Center for Astrophysics. The one inescapable fact about the moon is that it orbits the Earth. It is up there, beaming down on us, but according to everything that science knows, it shouldn't be. As we have discussed, it is known that people have been moon-gazing for tens of thousands of years, and our understanding has grown to a point where we are now very confused. The Greeks were great gatherers of knowledge and investigators of the rules of nature. In the 5th century BC, Democritus, who originated the theory that matter was made of invisible units he called atoms, went to the other end of the scale and suggested that the markings on the moon could be mountains. A little later, Eudoxus of Cnidus, who was an astronomer and mathematician, calculated the Saros cycle of eclipses, and thereby could predict when they would appear. Around 260 BC, yet another Greek by the name of Aristarchus devised a method by which he thought he could measure the size of the moon and gauge its distance from Earth. He never actually achieved it, but a mathematician and astronomer of major importance, known as Hipparchus of Rhodes, achieved the feat around 100 years later. He used an ingenious technique that was conducted during a solar eclipse. The eclipse in question was total in Syene, but only partial in Alexandria, which was some 729 kilometers away. Enlisting the help of like-minded friends, Hipparchus was able to use the known distance from Syene to Alexandria, together with the angular difference of the total and partial eclipse, to establish the moon's true size and distance from the Earth. At the end of the 1st century AD, Plutarch wrote a short work about the moon, entitled On the Face in the Moon's Orb, where he suggested that the markings on the face of the moon were caused by deep recesses, too deep to reflect sunlight. He proposed that the moon had mountains and river valleys, and even speculated that people might live there. Although a Hindu astronomer, Aryabhata repeated and confirmed the experiment conducted by Hipparchus as late as 500 AD. Christian authorities at the time maintained a biblical approach to the moon, and only information about our near neighbor that didn't contradict the scriptures was countenanced. With the arrival of Christianity, the world entered a dark age where scripture, rather than science, was the only permitted guide to human existence. The grip of the church slipped somewhat during the 15th and 16th centuries, and the Renaissance, literally meaning rebirth, emerged, bringing radical and comprehensive changes to European culture. The Renaissance brought about the demise of the Middle Ages, and for the first time, the values of the modern world made an appearance. The consciousness of cultural rebirth was itself a characteristic of the Renaissance. Italian scholars and critics of this period proclaimed that their age had progressed beyond the barbarism of the past, and had found its inspiration and its closest parallel in the civilizations of ancient Greece and Rome. By the end of the 16th century, a genius from the town of Pisa, called Galileo Galilei, became one of the most important scientists of the Renaissance, carrying out experiments into pendulums, falling weights, the behavior of light, and many other subjects that captured his imagination. Above all, for most of his adult life, Galileo was an avid astronomer. In May 1609, Galileo received a letter from Paolo Sarpi, telling him about an ingenious spyglass that a Dutchman had shown in Venice. Galileo wrote in April 1610, "About 10 months ago, a report reached my ears that a certain Fleming had constructed a spyglass by means of which visible objects, though very distant from the eye of the observer, were distinctly seen as if nearby." Of this truly remarkable effect, several experiences were related, to which some persons believed, while others denied them. A few days later, the report was confirmed by a letter I received from a Frenchman in Paris, Jacques Baudouvier, which caused me to apply myself wholeheartedly to investigate means by which I might arrive at the invention of a similar instrument. This I did soon afterwards, my basis being the doctrine of refraction. From these reports, and by applying his skills as a mathematician and a craftsman, Galileo began making a series of telescopes with an optical performance much better than that of the Dutch instrument. His first telescope was made from available lenses and gave a magnification of about 4 times. But to improve on this, Galileo taught himself to grind and polish his own lenses, and by August 1609, he had an instrument with a magnification of around 8 or 9. He quickly realized the commercial and military value of his super telescope that he called a perspicillum, particularly for seafaring purposes. As the winter of 1609 brought colder, clearer nights, Galileo turned his telescope towards the night sky and began to make a series of truly remarkable discoveries. The astronomical discoveries he made with his telescopes were described in a short book called The Starry Messenger, published in Venice in May of the following year, and they caused a sensation. Amongst many other findings, Galileo claimed to have proved that the Milky Way was made up of tiny stars, to have seen 4 small moons orbiting Jupiter, and to have seen mountains on the moon. As with many of his scientific investigations, Galileo could easily have fallen foul of the church authorities if his drawings of the moon had been made public. According to Christian tradition, both the sun and the moon were perfect, unblemished spheres. They simply had to be so, because God had created them, and none of the Almighty's creations could be flawed. Eventually, Galileo was put under perpetual house arrest by the papacy for his blasphemous claim that the sun was at the center of the solar system. It was therefore quite possible that he knew more about the moon than he was willing to admit in public. In order to explain the markings on the moon without treading on the toes of the church, a number of ideas were put forward in Christian countries. Perhaps the most popular of these, at least for a while, was the suggestion that the moon was a perfect mirror. If this was the case, there were no markings on the moon, but rather reflections of surface features on the Earth. It didn't seem to occur to anyone that as the moon orbited the Earth, the markings should change, since the land beneath it would not remain constant. Another suggestion, and one that was accepted in some circles, was that there were mysterious vapors between the Earth and the moon. The images, it was suggested, were present in sunlight, and were merely being reflected from the vapors. But the most popular theory, probably because it didn't impinge on Christian doctrine, was that there were variations in the density of the moon, and that these created the optical illusions we see as markings on the moon's surface. This unlikely explanation was safe, though it probably did little to convince early scientists, and certainly would not have impressed Galileo. After Galileo's time, telescopes improved markedly, and it was obvious to anyone who studied the moon that it was a sphere with a rocky and undulating surface. As the Church gradually lost its power to direct scientific thought, many of the earlier ideas regarding the moon became unthinkable. But no one had any idea how the moon came into being, and why it occupied the orbit it did around the Earth. It didn't take long for the subject of the moon to become very important to astronomers. Empires such as those created by Britain, France, and Spain were expanding. This necessitated long sea voyages, and led to that most urgent of searches, a way to plot longitude whilst at sea. It is quite easy to establish one's position on the planet in a north-south line, latitude, but it was impossible to know where you were in terms of east-west, longitude. In the northern hemisphere, for example, latitude can be quickly gauged by measuring the angular distance between the horizon and the pole star. This angle also defines one's position north of the equator. The longitude problem was eventually solved by having an extremely accurate clock on board a ship that was set to the time at one's point of departure. It wasn't difficult to work out the difference between local time, say at midday, and a time at home port. It was then simply a matter of adding or subtracting to discover one's true position on the Earth's surface. This was fine, but it took many decades before a suitably accurate clock could be created. In the meantime, astronomers sought for other methods to determine longitude, not least of all because there was a fabulous prize on offer for anyone who could crack the problem. And the place where many of them turned to establish longitude was the moon. Astronomers proposed that if really accurate tables were kept of the moon's position relative to the background stars, it would be possible to assess the true time of day in one's home port. The reason this could work was that the moon, being very close to the Earth and orbiting quickly, moved across the heavens by around 13 degrees of arc per day. Using the moon, it was a fairly simple matter to establish local time, and then to do the necessary computations to discover one's position. The lists of tables necessary to accomplish the task were not so simple, however, and as soon as good chronometers were available, the moon was abandoned as a means for longitude assessment. However, the desire to solve this problem, and the potential profitability of doing so, meant that the moon was receiving a great deal of attention during the 17th century, and very accurate maps of its surface began to appear. It wasn't until the 19th century, however, that probably the first reasoned explanation as to the moon's origin was put forward. George Darwin, the son of Charles Darwin, the controversial Englishman who first proposed the theory of natural selection, was a known and respected astronomer who studied the moon extensively and came up with what became known as the fission theory in 1878. George Darwin may have been the first astronomer to ascertain that the moon was moving away from the Earth. Working backwards from his knowledge of the rate the moon was receding from the Earth, Darwin proposed a time that the Earth and the moon could have been part of the same common mass. He suggested that this molten viscous sphere had been rotating extremely rapidly in about 5.5 hours. Darwin further speculated that the tidal action of the sun had caused what he termed a fission, a moon-sized dollop of the molten Earth spinning away from the main mass, and eventually taking up station in orbit. At the time, this seemed very reasonable, and was the favoured theory by the beginning of the 20th century. In fact, the fission theory did not come under serious attack until the 1920s, when a British astronomer called Harold Jeffreys was able to show that the viscosity of the Earth in its semi-molten state would have dampened the motions required to generate the right sort of vibrations necessary to fulfill Darwin's fission. A second theory that once convinced a number of experts was the co-accretion theory. This postulates that the Earth, having already been formed, accumulated a disk of solid particles, a little like the rings of Saturn. It was suggested that, in the case of the Earth, this disk of particles ultimately came together to form. There are several reasons why this theory can't be the answer. Not least is the problem of the angular momentum of the Earth-Moon system that could never have been as it is if the Moon had formed in this way. There are also difficulties regarding the meltings of the magma ocean of the infant Moon. The third theory regarding the origin of the Moon that was in circulation around the time that the first lunar probes were launched was the intact capture theory. At one time, seeming to be the most attractive possibility, the intact capture theory suggested that the Moon originated far from the Earth, and that the Moon became a rogue body that was simply captured by the gravitational pull of the Earth, and that it took up orbit around the Earth. There are many reasons why the intact capture theory is now disregarded. Oxygen isotopes of the rocks on the Moon and on the Earth prove conclusively that they originated at the same distance from the Sun, which could not be the case if the Moon had been formed elsewhere. There are also insurmountable problems in trying to build a model that would allow a body as big as the Moon to take up orbit around the Earth. Such a huge object could not simply drift neatly into an Earth orbit at low speed, like carefully docking a supertanker. It would almost certainly smash into the Earth at a massive speed, or possibly skim off and hurtle onward.
Most certainly.
By the middle of the 1970s, all previous theories about the way the Moon had been formed were running into